Okay, so this method is called the washer method. Okay, the method we've been doing the last couple days was called the disk method, right? The disk method we use when it's completely solid, when the object that's being created is completely solid, 100% solid. Today, part of it's not going to be there. There's going to be a solid, but then there's also going to be a hollow part, right? So that's why I put a picture of a paper towel here. This is a solid except for the middle, right? The middle has a tube in the middle, which is completely hollow, right? That's kind of like the shapes we're talking about today. So when we have shapes like this, we have to use, when there's any hollowness in there, we have to use what's called the washer method, okay? If it's completely solid, we use the disk method, which we did the last couple days, okay? So this is what they look like. This is what it looks like. So let's see if I can make it a little bigger. There we go. Okay. What's going on? I'm trying to reload this. Let's see. Something wrong. It was just working. Let me try the other link. Okay, here we go. So that's a function similar to what we've been doing, but you can see the area between the curves, the area bounded, I should say, is that part there. Okay, the red part. So now it's going to be revolved around the x-axis, right? It's revolved around the x-axis. So when it revolves around, when it revolves around the x-axis, it's not completely solid. It's got a little bit of hollowness there, right? It's got a little bit of hollowness. That's the type of shape we're going to run into today. That's the only difference. Everything else is the same. It's still the same revolutions, right? Revolutions over a horizontal line or over a vertical line. That's still the same. If you look at the formula, it's very similar. It's got some r's. It's got two r's squared. Pi still there. A to b, dy or dx or dy. That's all the same. But we just have to account for that hollowness, that part that's not there, right? Because if we didn't account for it, it would be the disk method, which it's not. It's not going to be, it's not the same exact shape as yesterday, right? It's similar shape, right? It's kind of that sideways cut, but it's got a hollow piece in there. Okay. So now what we're going to do is we're going to find volume of one of these guys here. One of these guys, just like we did last time, right? The difference today is that this isn't a disc. It's not a solid disc, right? It looks like a washer. It looks like if you've seen a metal washer, that's what it looks like, right? That's why it's called the washer method. Okay. So we're going to find volume of one of those guys to try to find the volume of the entire thing. Okay. So that's the kind of shapes we're looking at today. Okay. All right. So again, this kind of thing here, where if the metal, if the, sorry, not the metal, if the tube in the middle wasn't there, it would be completely solid, right? But because it's a tube, we would have to use the washer method. Okay, and then the next slide shows, this is what I'm talking about by washers. So horizontal axis revolution, so it just depends on where we're revolving around, right? And that's what they mean by washer, because there's going to be a hole in the middle, okay, of all of these things. All right, so the first four examples are all related. I did this on purpose so that we didn't have to redraw or draw anything new. Okay, so let's jump right into it. So again, these are non-calculator questions. I didn't put since the first one we did calculator questions, I wanted to give you some that were non-calculator questions. So I deliberately put non-calculator questions on this whole thing. Okay. So we got to find the volume of the solid created by revolving the region enclosed by y equals x squared plus 1, y equals 1, or sorry, and y equals 2, and it revolves about the x-axis. So just reading it, if you were to see this one on a test, would you know if this was washer method or disk method? Just by reading it. Does it tell you anything about whether it's a problem that we could have done on our notes 2 days ago? Does it tell you anything about that? Do you know anything about it? No, we don't, right? We know absolutely nothing about it. That's where the picture is going to help. The picture is going to tell you everything. The picture will tell you whether it's disk or washer, and I'll tell you why. I'll tell you when we draw the picture. Okay? So first thing I'm going to do is I'm going to graph it. I'm going to draw a quick graph for this. Just try to be as on scale, as to scale as you can. Obviously, it's freehand, so it's not going to be perfect. Okay? So the first one, I'm not going to draw the quadratic first. I'm going to draw y equals 2. Okay? So y equals 2 is a horizontal line going right through y equals 2. So y1, y2. I'm going to label that y equals 2. And then it says it's going to revolve about the x-axis. So I'm going to draw that line too. That line is called y equals 0. Okay. Now the only thing left to draw is the quadratic. Okay. The quadratic is y squared plus 1. It's a regular parabola. Regular parabolas look like this. The only difference is it's got that plus 1. So what is that plus 1 going to do to that parabola? What is it? What is the transformation? What is the only thing that's going to change from this parabola to this parabola? What's the transformation going to do? Yeah, you ready? It's going to shift everything up 1. Okay, so it's going to look exactly the same. It's just going to look, its vertex is going to be at 0, 1. Okay, if you didn't know that, just make dots. Easy way, make dots. So if I plug in 0, I get 0, 1. If I plug in 1, I get 2. If I plug in -1, I still get 2. So there it is, just a regular run-of-the-mill parabola, nothing fancy about it. It's just been shifted up 1. Okay, and this is y equals x squared plus 1. Okay, so that's everything they've given me. And then they say find the volume of the solid created by revolving the region enclosed. So where is the region enclosed? Well, there's only one area that's completely closed in, and that's this area right here. That's the only area that's completely fenced in. Everything else is not. So that's the region they're talking about. Okay. So now this green guy is going to revolve around the x-axis. It's going to revolve around the x-axis, right? So is that a dy or is that a dx? Is that a dy or is it a dx? It's a dx, right? We're going to have a dx. Let me write this down here. So we're not ready to calculate volume yet, but when we are, it's going to be dx. Okay? Okay, so now, why is this different? How is this different than what we've been doing the last 2 days in your notes and on your assignments with the disk method? How is this different? What differences do you see right now? Hmm?
This method will be calculating like from the values that are given to the line that, like for example, they give us the x-axis, we would be calculating it from both, like there would be no gap.
Exactly. There you go. There would be no gap. Look at the one. Let me show you one we've done before. There's one we did before. And we were revolving around the x-axis. Was it the x-axis or the y-axis? The y-axis, right? It's touching. The green part is touching the revolution, the line of revolution, right? It's touching it. Let's look at another one. The line of revolution here is the y-axis. The green stuff is touching the line of revolution, right? The y-axis, right? The one right before that. The line of revolution is y equals 1. Y equals 1. The green stuff is touching, right? It's always touching it. It's always the green and the axis of revolution. It's one of the bounds, right? If that's the case, it's going to be disk. If it's not the case, it's always going to be washer. That's how you can tell. And again, you can't tell unless you have a picture. If you have a picture in front of you, you can tell, oh yeah, it's revolving around y equals 0. The green is not even touching it, right? The green is not touching y equals 0. So that means it's going to be washer method. I'm going to use this method instead of the other method. Okay? Okay, so that's the way to tell. So since we know, we have 2 things to find. We got to find big R and we got to find little r. Right? Big R and little r. That's what we got to find because we got to subtract them. We got to square them and then subtract them. Okay? Okay. Big R. Let's start with big R. Big R is the axis. It goes from the axis of revolution to the outer boundary, top minus bottom. Okay? We always start with the axis of revolution and then we go to the outer boundary. Okay. So let's go there. So I want you to put your pencil on the axis of revolution. Put it on the axis of revolution. So like, let me use a different color. Let's use not green. I'm going to put mine right there at that dot. I'm starting on the axis of revolution. And I'm going to move my pencil up until it hits the outside boundary, the outside of the green. Okay? So if my pencil was here, I would move it up straight segment until it hits the outside. If I go too far, I'm off of the green. The outside of the green is going to be this guy right here, that guy right there. Okay? So that, let me draw it, is how you find big R. Big R goes from dot to dot. Okay? So we're going to go top minus bottom. So top dot minus bottom dot. Where is the top dot at? Which function is the top dot at right now? Y equals 2, right? This is with respect to x, so everything needs to say y equals. It already says y equals, so I'm just going to put a 2. I'm going to put a 2, and then it's minus, right? It said minus, top minus bottom, right? Where's the bottom dot at? Or is the bottom dot at? Y equals 0. Oops. This is what I'm going to put 2 minus 0. What is 2 minus 0? 2, right? I'm going to put that for big R. That goes in there for big R. Okay. I'm going to do the same thing, except now I'm going to use the inner, right? For little r. Little r is the inner. This is going to, so what I did is this. What I did was I found the center to the edge of one of these washers. That's what I found. That's what I just did. Now what I got to do is find the center to the edge of the inner side. That's what I got to do now. Okay. So to do that, I'm going to start with the axis of revolution and go until I hit an inner boundary. Okay. I'm going to use a different color. Start on the axis of revolution. And I'm going to move my pencil up until I hit an inner boundary, not an outer one like I did before. So which function am I going to hit? That would be an inner boundary. The blue function, y equals x squared plus 2. That's the inner side. That's going to be the inside, right? So now what I'm going to do is go top dot minus bottom dot. Okay. So top dot, hit y equals x squared plus 2. It already says y equals, so all I need is an x squared, or plus 1, sorry. Minus, since it's got two terms, I'm just going to put it in parentheses. And where's the bottom dot hit? Bottom dot's always going to be the axis of revolution. In this case, it's just y equals 0. It won't always be y equals 0. So don't assume it's always going to be minus 0, just because it was on this problem. Okay? In fact, it won't be on the next problem. Simplify this. I get x squared plus 1. So that goes here, x squared plus 1. Okay? Before I start calculating, before I start doing any kind of, I can't use a calculator, so I'm going to have to do it by hand. But before I start doing any antiderivatives, fundamental theorem of calculus, what do I not have? The bounds, right? For dx, the bounds are side to side. The bounds are side to side. So the left edge of the green to the right edge of the green. And it looks like I already have dots there. Looks like I already have dots there, right here and right here. So it looks like it's at -1, +1. How can I be sure of that? How can I be sure of that, Justin? Set the blue one equal to the top red one, right? We did this the other day, but just in case. Set this guy equal to 2. So x squared plus 1 equals 2. And solve for x. And you'll get two answers. You'll get -1 and you'll get +1. Okay? All right, so -1, +1. Good. Okay. Now I got to simplify, okay, because I don't have the benefits of using a calculator, so I can't plug it in yet, but I need to simplify. So when I simplify, so volume is done. This is just review from 2 chapters ago, okay? Volume is done. So I go volume equals pi 1 to 2. 2 squared is 4 minus x squared plus 1 squared dx. Okay, before I do any type of antiderivative, I gotta multiply this guy out. Because u substitution wouldn't work. Because if I did u as this guy here and then du as this guy here, I don't have another x to cancel out this x here. So that won't work. So I have to multiply it out. Oh, did I change it? I don't know why. Thank you. Yes, should say that. Okay. So what I'm going to do over here is I'm going to multiply x squared plus 1 times x squared plus 1. First, x to the 4th. Outer, 1x squared. Inner, 1x squared. Last, plus 1. Combine these two guys, and you get 4x squared plus 2x squared, or sorry, x to the fourth plus 2x squared plus 1. Okay, let me move it back. X to the fourth plus 2x squared plus 1. Still in parentheses because it's minus the whole entire thing. So now I have to distribute the negative. Negative x to the fourth minus 2x squared minus 1 dx. I can combine the 4 and the negative 1 to make a positive 3. So I get negative x to the fourth minus 2x squared plus 3 dx. Okay. Now, antiderivative. So we'd get negative 1/5 x to the fifth minus 2x cubed divided by 3 plus 3x, and I have to evaluate from 1 to negative 1. Okay. So negative 1/5 minus 2/3 Okay. I'm going to plug in a 1. Oh, yeah. So each one of these guys has got a pi. Yep. Thank you. Yeah. Each one of those guys has got a pi in the front. And then plug in 1, plug in negative 1. All right. So over here, I'm going to get, was it negative 1/5 minus 2/3 plus 3 with pi in the front minus positive 1/5 plus 2/3 minus 3. Okay. So to combine these, we have to do some common denominators. Let's see, 15 is the common denominator, so multiply this by 3, by 3, by 3, by 3, oh, not by 3, by 5. And multiply this by 15. So I'm going to get negative 3/15 minus 10/15 plus 45/15. So I'm going to get negative 13 plus 45, 32. 32 pi over 15, because now I can bring in the pi. Over here, luckily it's going to have the same common denominator. So you're going to get 3/15 plus 10/15 minus 45/15. So you get 13 minus, so what is that going to be? Negative 32? Okay. Negative, negative means plus, plus. So we're going to get 64 pi over 15. Okay. Mm-hmm.
How come when you were doing that antiderivative, you didn't get like plus c?
Oh, yeah. Good question. Because we had bounds. Mm-hmm. That's a good question. We haven't done that in a while. If there are no bounds, plus c definitely, always. If there are bounds, don't have to worry about that. Mm-hmm. Okay. All right. Okay, so luckily the next is exactly the same. The only thing that's changed is that the axis of revolution is different. Okay. So you can use the same picture. In fact, I'm going to just cut and paste this picture. Okay. So volume is still finding volume. It's y equals x squared plus 1. Y equals 2. This time it's revolving around y equals negative 1. Y equals negative 1. Okay. So this guy here, redraw this. So now this guy is going to be down here. Everything else is the same. There. Still a dx situation because we're revolving around a horizontal line. There's a big gap between the axis of revolution, the line of revolution, and the green stuff. So that means it's washer method. Okay, so we're going to have to use washer method. So we're going to use a big R and a little r. Okay. So when I'm finding big R goes from the axis of revolution to the outer bound. Okay. So axis of revolution, outer bound. That's going to be big R. Okay. So the top guy is still 2 minus the bottom guy is not 0 anymore. It's a negative 1. So it's going to be 2 minus a negative 1, which is 3. Okay. Now I'm going to do the axis of revolution to the inner bound, little r. Okay. The top guy is still x squared minus 1, or plus 1, sorry, minus a negative 1. So it's going to be plus 1. Okay. Do the rest. Finish out the rest. Okay. So we get similar things, similar fractions. So over here, 3, 3, oops, 5. So we get negative 3/15 minus 20/15 plus 75/15. And then over here, we're going to get the same thing. So we're going to get positive 3/15, positive 20/15, and positive 75/15. Which one? Oh, yeah. Right. And then what do you get? What do you guys eventually get? What do we eventually get? Nothing? We're still working? Huh? 104 pi over 15? Okay. From there, it's the same thing. Like from here on the screen, that's just, you guys can do that. It's not calculus. You guys can do that on your own. If you made a mistake, you guys know it's not a big mistake. You guys can figure it out. Okay. All right. Now we have this one. Okay. So now we have x squared plus 1 still. We have y equals 2 still. Good there. But now the axis of revolution is going to be above. Okay, the axis of revolution is going to be above everything has been before. It's not going to change anything. But it will just look different. It'll look different. Okay, so let's take a look at that one. So the axis of revolution is now, I'm going to say 5 is up here. We'll say 5 is up here. Okay. All right. So that's what it's going to look like now. Same thing, though. We're playing the same game. Okay. The axis of revolution is still not touching the green. It's not touching the green. So it's still going to be washer method. That's why we're still using washer method. Okay. If the axis of revolution was this line right here, we wouldn't need washer method. We would use the same method we did yesterday and the day before, which was disk method, because the green is touching that line, that highlighted line. But since it's not touching this, it's going to be washer method. So we got to find R first. Then we got to find little r. Then once we do that, we can plug it into this guy. Okay. All right. So here we go. Big R. Big R starts from the axis of revolution. Okay. So axis of revolution, it starts. Okay. The axis of revolution is y equals 5. There we go. Right there. I'm going to start right there. This time I can't go up. I got to go down. You're going to go down to hit the outer boundary. So when I go down to hit the outer boundary, which is the outer boundary? The blue. The blue is now the outer boundary. It's been the inner before. Now it's the outer. Okay? So you're going to go top 5 minus bottom, which is the blue, x squared plus 1. Okay? Now the inner. So the outer boundary, or the axis of revolution to the inner boundary. So 5 minus 2 this time. Okay, that's going to be little r. So when I distribute, I get 5. Actually, you know what? Let me do that first. 5 minus x squared minus 1. So we get 4 minus x squared. 4 minus x squared. And then the other one's just going to be 3. Okay. Finish out the rest. Okay. Finish out the rest. Good? Not good? Okay.
Oh, okay. No, I made everything. I made everything.
All right. Okay, so we're going to do, tomorrow we'll finish. I'm not sure if we'll get to all of them, but we'll definitely get to the next question, because the next question is the other way revolving. So revolving in the dy method. I definitely want to do that one. And then maybe one more. I don't know if we're going to do every problem in here because they're kind of the same problem. I might let you guys just get started on the assignment. But we'll finish tomorrow. All right, guys.